Welcome to Study Loop.
In this problem, we're asked to find the moment of inertia of a thin rectangular plate for two different axes that differ from the value we're given. So for this problem, we need to use the parallel axis theorem, which means there will be minimal calculation involved. And we just need to consider somewhat carefully the phrasing of the axes to make sure we get them correct. So our parallel axis theorem that will apply tells us that our moment of inertia about any point I is equal to the moment of inertia about the center of mass plus m times the distance d between the center of mass and the axis I that we're looking at, and that distance squared. Now, looking at part A, the axis that we're looking at is phrased the moment of inertia about an axis in the plane of the plate, passing through the center of the plate and parallel to the given axis. So this is the same as the I1 from the table that we were given, except it's going to be translated by a distance a over 2, and it's going to go through the center of our plate here. And so this is our I2 in red here. And so we can say our I2 would be the I center of mass, so it should be smaller than our I1 that we're given. And so we just rearrange the I center of mass equation. So we get ICM, and that's going to be equal to our I2, and is equal to I1 minus MD squared, so 1/3 MA squared minus M times A over 2 squared. So we'll have a 1/3 MA squared minus 1/4 MA squared, and that will give us 1/12 MA squared. And that will be our moment of inertia for part A. And then part B. Let's consider what the phrasing of the axis was. So it's the moment of inertia about an axis in the plane of the plate, passing through the center of the plate and perpendicular to the given axis. So what we have here is just rotated 90 degrees, and again, going through the center of the plate. So this I3 in green here is our axis. And so we can just, looking at the problem here, our length and width, A and B, are really interchangeable. They could be either one. So I3 is going to be the same as I2, except we're going to change the A to a B. So it's just rotating part A by 90 degrees. And so our I3 is going to be equal to 1/12. And instead of a length A, it's going to be a length B squared. Right.